morning class. Today we are going to learn electric potential due to a dipole. Previously we have learned electric potential due to a point charge. Now in this class we are going to learn potential due to dipole. Okay, so we know what is dipole. Dipole is an entity or a system in which two equal and opposite charges are separated by a small distance. Okay, that is called dipole. Now we will draw a dipole first. We have considered a dipole AB, okay, whose length is twice a, this is center, this length is A, and this length is also A, okay. So this is the dipole which we have considered. Now let us consider a point at a distance r from the center of the dipole, say P. Now we are going to find potential at this point due to the dipole. Okay. So now join this point from the end of the dipole. Now we have joined this point P and A, P and B. A and B, they are the end point of the dipole. Okay. Now this point P is at a distance r from the center of the dipole. So r is the distance, that is r is the distance of this point from this center of the dipole, and name this center as O. Okay. Now name this angle theta. Automatically this angle will also be equal to theta. Now you do one thing, you draw a perpendicular from this point to this line. Okay, draw a perpendicular. This is a perpendicular to this line, that is N, name it as N. Draw another perpendicular from point A to this line. Say this is N. Okay, so we have drawn two perpendiculars to this line. Which line? The line which is passing through the center and joining the point P, or passing through the point P and center of the dipole. Okay. So we are finding potential at point P. So we gonna have potential from this charge due to this charge at point P, and another potential due to this charge at point P. Okay, so we can write V1 is equal to potential due to minus Q at point P. Similarly, V2 is equal to potential due to plus Q charge at point P. Done? Clear? So what is the value of V? As per the formula or as per the previous topic, previous knowledge, what is the value of V1? So we have V1 is equal to, V1 is potential due to a charge, will be equal to 1 by 4 pi epsilon naught. What is the charge? Minus Q divided by distance between the charge and the point. What is the distance? PA. So we can write PA. Clear? Or simply write down PA. Question 1. Similarly, find the value of V2. V2 will be equal to 1 by 4 pi epsilon naught plus Q. And what is the distance between P and B, that is PB. Equation 2. Okay. Now see, in this triangle, see, in this triangle AMO, in triangle AMO, cos theta is equal to, cos theta will be equal to base by hypotenuse. If you consider this angle and you are taking cos theta of this angle, cos of this angle will be equal to base. This will be the base and this will be the hypotenuse. So base, what is the base? OM. OM divided by what is hypotenuse? If this is theta, then what is the hypotenuse? This is 90 degree, this is the hypotenuse. Okay, that is AO. Done. This implies that OM is equal to, transpose this to this side, AO cos theta. Clear? And what is the value of AO? OM will be equal to A cos theta. Done. Similarly, in triangle, next triangle B and O. B and O, cos theta will be equal to ON divided by OB. This implies that ON is equal to A cos theta. See? ON base and this is hypotenuse, ON by OB. Okay? ON by OB. Done. Equation 3, equation 4. Up to this clear, na? Now, if the dipole is very small, that is A is very less than R. So we're gonna have PA will be equal to or PA will be similar to PM. Okay, clear? So what is the value of PM? See in the figure, PM will be equal to PO plus OM. We can write PO plus OM. So what is the value of PO? PO, what is the value of PO? R plus, what is the value of OM? A cos theta. Okay. Now next, again, or we can say similarly, PB is similar to PN. If the dipole is very small, then this PB will be similar to PN. Okay. So what is the value of PN? PN will be equal to PO minus ON. Then, so what is the value of PO? R minus A cos theta. Clear? Everything is done? No doubt. Now next, we have OM is equal to, what is the value of OM? Sorry, we have V that is total potential at point P, total potential at P will be equal to V1 plus V2, that is 2. Okay, done. So what is the value of V1? What was the value of V1? 1 by 4 pi epsilon naught minus q by PA. Okay. Now what is the value of PA? PA is similar to PM, so we can write PM. Okay. Plus V2. What is the value of V2? 1 by 4 pi epsilon naught Q by PB. So we can write in place of PB, PM. Now take out the common terms. What are the common terms? Take out the common terms. 1 by 4 pi epsilon naught Q inside bracket minus 1 by PM plus 1 by PM. Then clear up to this. I am writing this. Now B is equal to Q by 4 pi epsilon naught minus 1 by, what is the value of PM? What was the value of PM? PM is equal to R. PM is equal to R plus OM. R plus A cos theta. OM value is A cos theta. Plus 1 by, what is the value of PM? R minus A cos theta. Clear now to this. Now next, sorry, Q by 4 pi epsilon naught cross multiplication A plus B, A minus B, A plus B, A minus B whole square. Okay. A plus B into A minus B, A square minus B square. Sorry, A square minus B square. This is the formula. Okay, identity. Now solve the numerator. A is equal to 4 pi. Solve the numerator. So after solving this, we will get this. Now minus r plus r, they will cancel out. A cos theta will be equal to Q by 4 pi epsilon naught inside bracket Q A cos theta divided by r square minus A square cos square theta. Okay, this is V. So now V is equal to Q, just we are rearranging, okay? So we can write 1 by 4 pi epsilon naught twice A Q cos theta by r square minus A square cos square theta. What is the value of twice AQ? Twice AQ is equal to dipole moment of the dipole, okay? So we can write have V is equal to 1 by 4 pi epsilon naught P cos theta by r square plus A square cos square theta. Okay. This is the formula of potential due to a dipole at any point from distance r from the dipole of the dipole. ठीक है. If now we're going to discuss three cases. Number one, if the dipole is very small, if dipole is very small, then A is very smaller than R. A will be very smaller than R. Then A square can be neglected. Okay. So in this formula, see, if A square can be neglected, then only remaining term is this term. Okay. So we can write V will be equal to 1 by 4 pi epsilon naught P cos theta divided by R square. Okay, this is the potential. Now case 2, if the point is axial line. If point is an axial line, then theta will be equal to 0 degree. Here now put the value. G will be equal to cos 0 is 1. So 1 by 4 pi epsilon naught P by R square plus A square. Okay. Then now last, not the least, if case number 3, if point is at equatorial plane. Point is located on the equatorial plane, then theta will be equal to 90 degrees, and V will be equal to cos 90 equal to 0, and V will be equal to 0. Okay. So our next topic will be equal to equipotential surface. Equipotential surface. Okay, this is our next topic. Okay, thank you.